Okay, we are going to be working this problem here. We're going to be doing 3 problems and figuring out what equation we need to use and what steps we need to follow. So when we look at this, it says we have carbon dioxide in the solid state. We have 1.28 grams of dry ice. And we're putting it in a 5.00 liter chamber that is maintained at 35.1 degrees Celsius. What is the pressure? So a couple of things to note. First off, we have 1.28 grams of CO2. We have 5.00 liters given to us. We have 35.1 degrees Celsius given to us. And we want to know pressure. So when we see this grams here, we know we're going to have to convert that to moles. And the way we do that is by dividing by the molar mass, right? And the molar mass for that is going to be 44.009. So that will tell us how many moles we actually have of this substance. So if you put that in your calculator, you should get 0.029085. So that's going to represent our N. We have an L here, which was going to represent V, because that's a volume. And we have a temperature here, but that is in Celsius, and we need it in Kelvin. So we're going to add 273, so that is representative of the correct unit of temperature we have. So that'll give us 308.1 Kelvin, which is a temperature, which is T, and this is moles. So, moving on into the next part, we've got, we're looking for pressure, right? So we don't know what pressure is in this case. So we have NVT, and we're looking for P. And we know of this equation that we've been using called PV equals nRT, which is going to help us solve this problem because none of the other ones would have worked. We have too many variables. But with that, we do need to figure out which R we want to use. And since this is at we want to know what the pressure is. And we're just going to go ahead and assume that we're going to be in ATMs. So that means our R is going to be 0.0821. And remember, the units for that are atmosphere liters per mole Kelvin. So we're in atmospheres, we're in liters, we're in moles, and we're in Kelvin. So we need to make sure we have all of that correct. And then we can start plugging things in. We can put P, we don't know. V is 5.00 liters. I'm going to leave off the units when I put this in here just for space because I don't have a ton of space to work with here, and I got some pretty big numbers. So we've got PV equals N. Our N is 0.029085. Our R is 0.0821. And our temperature was 308.1 Kelvin. So I know my decimals are super small on this screen, so just make sure you're being really, really careful of that. And then we do want to see where, okay, we've got P here that we're solving for. To get it by itself, we'll need to divide both sides by 5. So we're going to divide both sides by 5. And that is how we will get our final answer. So I'm going to let you solve that. Make sure you should get 222.64. And we would need to round to this 3 significant figures. So you would round up to 223. So that will be that problem. And now let's go ahead and look at the next one. So we have blast furnaces give off many unpleasant and healthy gases. If the total gas pressure, so the total is 0.998 atmospheres, we have a partial pressure for carbon dioxide, which is 5.065 kilopascals, and a partial pressure of hydrogen sulfide, which is 0.152 millimeter of mercury. What's the partial pressure in atmospheres of the remaining air? So we're going to be using, we've got a P total, and we have a P of CO2, and we have a P of hydrogen sulfide, and we have a P of remaining air. We don't know what it is, so we'll just put air. So in order to figure out what P of air is, that means we've just got to subtract these two out of our total, right? But they're not in the same units. So that's a problem for us. We need everything in atmosphere. So we're going to have to make 5.065 kilopascals. And we're going to have to convert that to atmospheres using this conversion factor. So for every 1 atmosphere, we have 101.3 kilopascals. And then for millimeter mercury, for 15.2 millimeters of mercury, that conversion is 760. So we could put equal signs there. And so once you find those, they will be in atmosphere. So everything has to be in the same unit. This first one here is going to be 0.05 atmospheres. And the second one, if we take 15.2 divided by 760, we get 0.02 atmospheres. So we're just going to plug everything into that equation up here, this one. So for P total, we have 0.99, and we're going to subtract 0.05, and I'm running out of space, so we're going to subtract 0.02, and that will tell us how much the remaining air was. So the remaining air is 0.92 atmospheres. And that's how you solve that one. So it's really not that hard. You're just thinking of like, okay, if I have 5 apples, I give 1 away to somebody, 1 away to somebody else, how many does the other person get, right? So let's go ahead and look at another problem really quickly. This is a little bit different than the one we just did. So it'll be important to go over this. So if we have this many moles of N2 and this many moles of O2 in a 45-liter container, at a temperature of 45 degrees Celsius, what is the total pressure? So we have an N of 1.50 moles. We have another N of 4.00 moles. We've got a volume of 45 liters. And we have a temperature of 45 degrees Celsius. And we want to know, what is the total pressure? So we have 2 N's, a V, a T, a P. We know we're going to have to use PV equals nRT, our ideal gas law, which means we're going to be working with an R. And that's going to be 0.0821. So remember I said if it's not given to you, go ahead and understand to use the atmosphere one. Just by default, unless you are in a different unit or it asks for a different unit. So we can go ahead and take a look at P. We don't know what P is. That's what we're looking for. For V, we have 45.0 liters. For N, since we're combining this and we're saying, okay, we want to know total pressure. So the total pressure is coming from both of these. So you can actually just add those up and get 5.50 times your R of 0.0821 times your temperature. The temperature is in Celsius, so we would need to convert that to Kelvin. So you would need to add 273. So 273 plus 45 is going to give you 318. So now we're set up as far as that goes. And let's go ahead and move over this 45 so that it's on this side, and we are left solving for P. So now we'll be left with P. And remember, it's going to be really important that you use units. I didn't just for the sake of space, but you would want to look at your units and see how they're canceling out in this situation. So the answer is 3.19095 atmospheres. However, we are limited by 3 sig figs. Well, actually, technically 2 because of the 45 degrees Celsius. But let's go ahead and base it off of 3. So we have to round down to 3.19. And that would be in atmosphere. So that is really all you have to do to solve these problems. And just be really careful that you're watching units. And that if it's a problem like this, you do have to add these moles together.